A box of mass 10 kilograms rests on a surface inclined at 30 degrees to the horizontal. The box is attached to a light, inextensible string which passes over a smooth pulley. The other end of the string is attached to an object of mass 2 kilograms. The coefficient of friction between the box and the surface is 0.1. What is the acceleration of the system when it is released? Okay, so let's start here. We know that this is 10g. And what we really want to know, since any motion will be parallel to the slope, are the components this way and this way. Now, if this angle here is 30, this angle here is 30. It's fairly easy to justify that. And that means that in this direction we have 10g cos 30, and in this direction 10g sine 30. There'll be a tension in the string, and the friction is going to act this way because when this system starts to accelerate, it's going to accelerate down the slope. At this end, since the mass is 2 kilograms, we're just going to have 2g and t, and this one is going to accelerate in this direction. Once we've resolved this 10g weight, we can essentially ignore it. So there'll also be a reaction with the slope. So if we look perpendicular to the slope, we must have r is equal to 10g cos 30, as those are the only forces acting perpendicular to the slope. If we look parallel to the slope, we're going to use F equals ma because there'll be acceleration. Down the slope, we have 10g sine 30. Up the slope, we have t and F. That's the resultant force on this particle. So that is going to be equal to 10a. Then if we look at the other object, so the other mass, we're going to have T minus 2g, that's the resultant force, is equal to 2a. Now let's call this equation 1 and this equation 2 for now. And let's call this one star. And sub star and mu equals 0.1 into equation 1. Then I have 10g sine 30 minus t, take away 0.1 times 10g cos 30. Remember, that's mu r, which is the limiting friction. That is going to be equal to 10a. Now we can do some calculation there. So if g is 9.8, 10 times 9.8 times sine 30. And the other thing that I know is just a number is the 0.1 times 10g cos 30. So I can take that away. 0.1 times 10 times 9.8 times cos 30. So altogether that gives me 40.513. Take away t is equal to 10a. let's call that 1 prime. And then I've got t minus 2g equals 2a, which is number 2. And these are simultaneous equations. So if I do 1 prime add 2, I get 40.513, take away 2g equals 12a, and therefore the acceleration is going to be 40.513 minus 2g divided by 12. And we can calculate that. So we have my last answer, take away 2 times 9.8, and we want to divide that by 12, and so that gives me 1.74 meters per second squared.